What's up everyone? Today we're going to go over Leetcode number 90, subsets with no duplicates. First I'm going to write out the code and then I'm going to draw out the recursive stack tree diagram so you can see how the subsets are each actually getting populated and which recursive stack is making each one of these subsets. The solution comes from the backtracking template by the Leetcode user Isaac3, so follow the code that I post below, and then it'll be easy to understand how the recursive stack is being generated. So first, let's make the data structure that they want as a result. It's a new ArrayList. And then what we have to do is sort the array, because that's how we're going to be handling the duplicates. And in the recursive part, you'll see that there's one if conditional which checks if a element and the previous element are the same. If so, we continue, but I'll write the recursive stack in a bit. DFS res, new array list. This is a temporary. Then we pass in the array itself, and then we pass in 0, which is going to be kind of like the position. So we start with the 0 position, and then each recursive call is going to be going +1, +1, +1. Then we return res. So that's the main method that is going to run the function. Now let's get into this recursive DFS function. Call this res, call this t for temp, integer array nums, and then int pos for position. So first thing we're going to do at the beginning of our recursive stack is always add the temp that was passed in. So add new array list t for temp. So the first one, when you pass in, it's empty. So it's going to be, I'll use a different colored marker, null set. Because when it's first passed in, it's empty. Then what we're going to do is for int I is equal to 0, or rather POS, but POS was 0 when it was passed in. So this is going to be POS. I is less than nums.length I plus plus if I is greater than POS and the element we're visiting is the same as the element that we had previously. We're going to continue. So what that means is if we're on this one, we're going to skip if the same thing is the same, if the number before is the same. Then we're going to add nums of I. Then we're going to recursively call this function. And what we're going to change is we're going to call I plus 1. So the recursive function gets the I that's next. So if we're starting out with 0, then it's going to recursively call 1 next. And then remove t.size minus 1. Now that's the general backtracking, is you add something to your list, you recursively call that, including it in your function. Then once that returns, you remove the thing that you added at the very end. Even for famous problems like a backtracking, like an n-queens problem, that's the idea of how backtracking works. So this is the code. Now let's get into what the diagram looks like. So first DFS res, that's the null set. Nums and 0 gets passed in. Res.add new array list. This one. So this is how we get our first one. Then we do our for loop for int I is equal to 0, I is less than 3, because num's length is always going to be 3 I plus plus. If I is greater than 0 and blah blah blah, then we continue. We don't need to continue at this point, that's why I'm just writing it like that. And then t.add nums of 0, which is going to be 1, coming from there. Then we do dfs res, pass in the newly added 1, then nums, and then I plus 1, which is going to be 1. Recursively we get called here dfs res 1 nums 1. So the first thing we do is we add the new array list to our data structure, and that's how we get our second answer from that. Then for int I is equal to 1, I is less than 3, I plus plus. If I is greater than 1 and blah blah blah, we continue. But we don't need that right now. Then recursively we add first nums of I, which is 1, and this is pretty much going to be 1 and 2. We recursively call, that's a recursive call, res 1 and 2 nums, and then 1 plus 1, which is 2, recursively call here dfs res 1 comma 2 is in the temp array, and then we passed in 2 here, right? So what we do is first we always add in the result new array list 1 and 2, and that's how we get our next one right there. For int I is equal to 2, I is less than 3, I plus plus. If I is greater than 2, blah blah blah, we don't need it right now. Then what we do is t.add nums of 2. Then we recursively call this dfs res 1 comma 2 comma 2 and nums array, and we pass in 3. Now this gets recursively called here dfs res 1 2 3 nums 3, and we add new al 1 2 2. This guy is here, and we get our final one here. And now because for int I is equal to 3, I is less than 3, this won't happen, so this recursive stack is done. Then we come here. Now we also have to t.remove the last thing, so t.size minus 1. Then what this becomes is 1 2 2 is the temporary array. So then we get I is equal to 3, right? To start out with 2, I is equal to 3, and it's not less than 3, so this recursive stack is done as well. Now we come here. Now once you do t.remove t.size minus 1, that pretty much removes this 2 right here. Then here it was I is equal to 1 less than 3. Now we're doing I is equal to 2 less than 3. This is the first time we're going to run into that if condition. If I is greater than 1, the 1 is coming from here, and I is 2 right now, and nums of 2 is the same as nums of 1, 2 minus 1, which is 1, then we continue. So this one is not going to happen. Then we do I is equal to 3 less than 3. That's not going to execute, so this recursive stack is done. So all we have left is the 2 and the 2. So now we also have to do the same thing, t.remove t.size minus 1. So the 1 goes away, and we recursively, now we do I is equal to 1, which is less than 3. We t dot add. We're going to add 2 pretty much, and then recursively call DFS on it. So res, it's going to get a little messy, but you should be able to understand from the rest of this flow. What's going to happen is 2 is going to get added at the top of this recursive stack. 2 nums, and then this is going to be 2 that's passed in, then res dot add new array list. So this is where we get our 2 from, and then here for int I is equal to 2, I is less than 3, I plus plus, we add t dot add one more time. So now it's going to be 2 comma 2, and this gets called recursively DFS, and this is res dot add 2 comma 2. So that's where we get our last, that one. Yeah, sorry I ran out of room, but that's how it would look like if the last recursive stacks were small enough to draw in here. Anyway, let's counter check. So 1, 2, 3, 4, 5, 6, and we got 1, 2, 3, 4, 5, 6. So that's how you solve Leetcode number 90. If you like the problem, if you like the video, please subscribe. It'll motivate me to make some more, and let me know how I can improve. And thanks for watching.